In this video, we're going to learn about piecewise functions. A piecewise function is like a puzzle made up of different rules. Each rule applies to a specific range of the input, or the numbers you're putting into the function. So, depending on the input value, the function follows different instructions, or formulas, to calculate the output. When we are asked to evaluate a piecewise function, we need to look at the input and then figure out which one of these intervals that input fits into. So x equals -5. So we're checking here, we're wondering, is -5 less than or equal to 0, or is -5 greater than 0? Well, -5 is less than or equal to 0, so it fits into this one. Now, this is just the interval for the inputs. What it's done is it's told us that we need to use this part of the function. So in other words, f of -5 equals 2 times the input plus 4. So since the input was -5, and -5 is less than or equal to 0, we use the first piece of the function. Okay, so let's work out this right side here. And we get f of -5 equals -6. Now we're going to evaluate the function at x equals 1. Well, 1 is greater than 0, so we're using the second piece of the function now. So f of 1 will equal the opposite of 4 over the input plus 8. Well, 4 divided by 1 is just 4, so we can get rid of the fraction. And when we add these two integers, we get 4. So f of 1 equals 4. So when you're evaluating a piecewise function, you use the intervals described on the right to figure out which piece of the function we need to use. Here we have another piecewise function, and we need to start by evaluating the function at x equals -10. So we're trying to figure out what f of -10 is. So we look at these intervals to see which one -10 fits into. And -10 is less than or equal to -6. So we're going to use the first piece of the function. So f of -10 equals 13 times the input plus 7. Because our x value fit into the first interval, so we use the first piece of the function. I will multiply, and then we'll add 7. So f of -10 equals -123. Now we need to evaluate the function at x equals 15. Well, 15 is greater than -6. So we checked which of these two intervals 15 is in. It's in the second one. So we use the second piece of the function. Now this piece looks a little different because there is not anywhere to put our x value. It's just 11. So that means that when x is greater than -6, the output, or the y, is always equal to 11. So in other words, f of 15 equals 11. Because if x is greater than -6, the output is always 11. Now this piecewise function has 3 pieces. We have a piece that we use when x is equal to -5, a piece that we use when x is equal to -7, and a piece that we use when x does not equal either -5 or -7. So in most cases, this function just has an output of -2. So let's evaluate the function at x equals -5. So if we plug -5 into the function called f, so let's look to see which interval this input falls into. Well, here it is. Our input is -5, so we're going to use the first piece. We're going to square the x and add 7. So we take our input and square it, and then add 7. Now -5 squared, that equals positive 25, because negative times negative is a positive. And when we add 7 to that, we get 32. So f of -5 equals 32, because our input was in the first piece, or told us to use the first piece of the function. Now we need to evaluate the function at x equals 28. Well, let's see, 28 does not equal -5, and it doesn't equal -7. So we end up using the third piece, because 28 does not equal -5 or -7. So that just means that no matter what the input is, the output is going to be -2, as long as x does not equal -5 or -7. So we have f of 28 equals -2. We can graph piecewise functions as well. And when we read a piecewise graph, we need to remember that the inputs here are the x values. And then what we're looking for the output. That will be the y value. So for this piecewise function, f of 9 will equal, let's see, 9 is over here. So if we go up to the graph, we're talking about this point right here. That's the point 9, 5. So when we have an input of 9, the output is 5. So we're looking for the y values on the graphs with these x values. Now we need to find f of 6. Well, the 6, that's going to be our x value. And we actually have to make a decision here. We're wondering which of these points we should use. Well, the point up here is an open point, and so that point is not included. But this one down here it's a closed point. And that is the point 6, -10. So when x is 6, the y is 10. Or when the input is 6, the output is -10. All right, finally we need to find f of 0. Or in other words, what's the y value when x is 0? Well, when x is 0, that means we're not right anything or left anything. We're right along the y-axis. Kind of funny how when x equals 0, we're on the y-axis. So we're talking about this point right here. That point has an x value of 0 and a y value of -4. So f of 0 equals -4. I hope these examples about piecewise functions have been helpful. This is Mr. Ela, signing off.